Okay, so let's talk ionic bonding. When we have main group elements, they are going to form ions so that they have the same number of electrons as the nearest noble gas. And sometimes that means going back to the previous noble gas, like for sodium. Sodium would go and lose one electron to become like neon, whereas fluorine would gain one electron to become like neon. And so the ones here on the left, oxygen and fluorine, are nonmetals, and they're going to gain electrons. Sodium and magnesium are metals, and they're going to lose electrons, but they all four become like neon in terms of electron configuration. And so that means they are isoelectronic, same number of electrons, same ordering of electrons. So, formation of ionic compounds means that we have some kind of a metal interacting with a nonmetal. And the metal is going to give up one electron. In this case, sodium is giving up its one electron to chloride. And we form a very strong attraction between these two elements because we have positive and negative. So these are like two ends of a magnet that when they come close together, they kind of snap together. That's because it's an ionic compound. And so they are very strong, and they're held together by electrostatic forces. The stability of a noble gas is because it is electron configuration, and that electron shell is full. And this full shell results in more stability. So as I said already, main group elements, which is a majority of what we're going to study, either gain or lose, or they may share electrons in order to have a filled valence shell. If it gains and loses, one atom gains and one atom loses, that would be an ionic bond. If they share, that's a covalent bond, and we'll talk about that in the next video. In either case, we now have elements that are isoelectronic with noble gases. So there are some exceptions to this in the main group, and that's when we get down into the lower rows like 6 and 7. And these main group elements, we call them post-transition metals, tend to have more transition metal properties, and so they form multiple ions. And so these are some that, although are not transition metals, behave similar to those, and we end up getting multiple ions. So these would also have Roman numerals in your naming. So like the second one here, SN2 and SN4, these two would be tin, and to tell the difference between them would be tin with the Roman numeral 4 and tin with the Roman numeral 2. Okay, going on. The transition elements and the intertransition elements behave differently than the main group elements. We can easily predict our main group elements. Transition and intertransition elements we have to kind of memorize. They're just harder to do. So they're not typically isoelectronic with a noble gas, and we are not studying any of the intertransition metals. You'll just have to memorize the transition metals that I've asked you to memorize. Anions usually form when the nonmetal gives up enough electrons to have a filled valence shell. No, they gain electrons. I don't know why I said give up. Anions usually gain some electrons until they have the filled shell, and that becomes a negative charge equal to the number of electrons gained. A metal and a nonmetal tend to transfer electrons. Oh, this is covalent bonding. We're going to start this in the next video. So I hope this helps, and I will talk to you soon. Bye.